thanks. This all started with a discussion that I had with Philipp in Bochum on ICDD and whether it makes sense, yes or no. And in that discussion, we agreed on a couple of things. Data interoperability is key in our industry, and we're not there yet. I think we heard that in the morning. Currently, I think a common approach is to use CDEs or common data environments that enable us to centralize project data. But what they lack is the availability to make data really interoperable across projects and also across life cycles. So it stays in the CDE, but is then kind of trapped there. And since we're seeing this trend of digital twins and using data in multiple life cycles of a building, also after the building, for example, using circularity, we thought that it would be that there's a need for a method to exchange static and dynamic data using uniform terminology, scalable web technologies, and secure data access control mechanisms. And yeah, we do have a standard that comes quite close, I would say, which is ICDD, which is based on the MMC concept and the coins concepts, which is essentially a zip file of information that we can then use to exchange data across partners. And it contains a couple of files, namely index.rdf, which is just an index of the rest, a folder with ontologies, a folder with documents, and this can be anything, IFC, GLTF, Excel files, etc. And then a folder with graphs, and these can be standalone graphs, but they can also be graphs that link information between the other files. So we have graphs that link the IFC file with the GLTF file, but also elements inside the IFC file with other files, etc. And this is nice for, let's say, can I call this old school data exchange, relatively static data exchange. So we exchange the zip file and then people extract it. But there's lack of standardized access policies, relatively limited web-based methods, and it's zip-based. But the nice thing is that ICD comes with these two ontologies, link set and container. And that they nicely describe how the relation between different types of files is orchestrated. Then there's this new concept, data spaces, that facilitate trustworthy and standardized data sharing and exchange between multiple stakeholders in, and this is important, distributed data ecosystems. And there's a couple of initiatives, some are a bit more general, some are in our industry. We'll focus on IDSA. So the reference architecture model that they made more or less looks like this. So there's a data owner on one side that has data, and then there's a data user on the other side. The data owner authorizes some kind of a data provider where they store the data. The data user authorizes a data consumer where they access the data. And the entire interaction between those two blobs is what we call data space. And technologically, this interaction is happening using so-called connectors, which are basically gateways to those blobs. And these are standardized so that, in theory, each blob can talk to each other blob. And how this is all managed is because we have certain technologies in that data space, such as digital identities, vocabulary providers, so ontologies, etc., and also apps. And this is a very nice global architecture, but you see that there's missing pieces to directly implement this in our AEC industry. Yesterday, Krista mentioned that there's no 19650 in here, and this is also mostly designed for IoT or data stream data, but not for the static files that we very often use. So we thought, can we use that ICDD specification that enables linking between those static files and somehow put that inside this framework so that we can deal with the static files inside data spaces. And what we technically did is we built an app for the left side of the thing, we built an app for the right side of the thing, and we built connectors to test whether ICDD would work in this regard. So on the data provider, the green side, we used the ICDD platform by University of Bochum, which serves ICDD containers using the OpenICDD API, which we extended with an IDS connector so that you can connect to this data space using a connector. And the communication method that we use to communicate between those connectors is Sparkle, because everything is semantic web here. And what we enabled is we can send a Sparkle query and it returns this multi-part byte ranges answer, which is basically a collection of different files in one output. And that can contain both zip files as individual files, metadata, etc. Yeah, and we expose this using a query pod, where you send a Sparkle query and then it returns that via this API. And that platform looks like this. So this is where a data owner can store data, and on the left side you can see how that is structured using the ICDD methods. And here you can update your data, you can look at your data, you can see who owns this, etc. Then on the other side of the spectrum, we created this marketplace app, which is built on top of LBD Viz. And it tries to communicate via these connectors with that other app using bearer authentication. So what it does is it sends a Sparkle query via these connectors to the other app using a bearer token. And then it returns or retrieves this multi-part encoding answer. Then the marketplace app automatically decodes that multi-part answer. And if there's a zip file, it will automatically extract that zip file. So we still have these zip files in the communication, but when we use it, then it's automatically extracted so that we can apply all these other web-based technologies there. If there's IFCs, they automatically load them in a viewer, so this is what it looks like. So this is exactly the same data as was in the RUB platform, but then in a different environment. So now the user can use that data, or some of the data, to build apps on top of it. So we tried this in a use case. So we had this case where in Bochum they are decommissioning 2 buildings, and there's some of these beams that they want to reuse or that have reuse potential. So for this building we have IFC, point clouds, radar measurements, RDF graphs, and we extended those graphs with circularity scores using Argavant's door ontology. And what the marketplace app then does is it sends this Sparkle query to this data space, asking for buildings with a certain decommissioning date, then for these buildings retrieving elements with a reuse potential that we structure using that door ontology, and then optionally for these elements give all the files that you have based on that ICDD specification. So then whenever it retrieves something, it will do this multi-part decoding and unzipping, and it then automatically shows all this information in the marketplace application. So here you can see one of the beams in that RUB building with information about when this is going to be decommissioned and what the potential of that beam is. So to conclude, we combined ICDD and data spaces, and this enables centralized access to decentralized data. We believe that ICDD provides one of the technical AECO specific solutions to this relatively abstract IDSA architecture. We extended existing work of Philipp and me. And what we find really nice is this decentralized use of information containers also supports like new themes in our industry, like circularity, etc. Simply because the data is provided where the physical elements are provided, namely in the owner's sovereignty. So for future work, we would like to define other AECO-specific technical solutions for this IDSA ROM architecture. Digital identities is still vague. The vocabulary hub is still vague. We'll hear more in the next presentation. Whether we should put this ICDD ontologies in the vocabulary hub is still vague. We would also like to focus on the software components, such as policies and management, and build other types of data consumer apps, because another app could use the same data from the same RUB platform. And that's it. Thank you for your attention.